Okay, so we have one more function we want to talk about, and that is tangent. Remember, tangent x, to make it one-to-one, is defined from negative pi over 2 to pi over 2, inclusive or exclusive, specifically negative pi over 2 to pi over 2. We cannot include negative pi over 2 or pi over 2 because tangent x is sine of x over cosine of x. Cosine at negative or positive pi over 2 is 0. Dividing by 0 makes professor's head explode. So let's see what the solutions are to this. And now I'm just going to pick one that I know. Hopefully everybody knows this one, or if you don't, you'll get it pretty soon. Suppose tangent x is equal to 1. For what values of x is this? Well, I know that this is 45 degrees, right? And that's pi over 4. So let's take a look at this. We'll draw a nice picture here, hopefully, of the unit circle. Oh, yeah. Yikes. Okay. You know, some days it just comes and some days it doesn't. So here's your 45 degrees, which is pi over 4. And this point on the unit circle is 1 over the square root of 2, 1 over the square root of 2. So where is this going to be equal to this again, if anywhere? And so here's the choices that we have. Here, here, or here to look for, right? But here's the problem. In this one, and let me, use this color. If we're, okay, so tangent is positive in the first quadrant, and it's positive in the third quadrant. In the second and the fourth, tangent, the y is going to be positive, but the x is going to be negative. So this can't be. Tangent will be negative. Same with this, only in this instance, x will be positive, but the y component will be negative, so it can't be this. So it must be this. Here is the triangle that we're going to deal with this here. And so what is this point? This point is negative 1 over the square root of 2, negative 1 over the square root of 2. However, when we take the tangent of this angle, which is this, right? That's what's represented here. The tangent of this will be negative 1 over the square root of 2 divided by negative 1 over the square root of 2. They cancel out, it will be 1. So the solutions to tangents, suppose we have x is equal to u, and in this case u will be pi over 4, plus, remember that tangent is periodic with period pi, so this will just be k pi. So in general, so look at what happened here anyway. So this is our first u, right? So in general, x will equal u plus k pi. But look what happened. So here's our first one, here's our second one, there's our third one, our fourth one, and going around either way. These are, everything I've just talked about is going to be very important, especially when you get to physics, and they will take off points like crazy if you don't put in both branches of the infinite numbers of solutions or anything like that. And if you don't remember it, you can, the whole point of doing the unit circle again and again is to get you to, you can figure this stuff out on the fly if you need to, and this is really handy for doing it. I think the best thing I can do for you now is to get some problems, and I'll show you a couple that usually cause a little bit of trouble. Nothing too big though. Okay. So hopefully you'll remember these because I'll need some more room. One of the problems that you've been assigned is, suppose you have sine 2x is equal to 1 over the square root of 2. And incidentally, this is also equal to the square root of 2 over 2. Remember, in the old days, with no calculators, it was very difficult to compute what this was on a slide rule. It was very difficult to compute what this was on a slide rule, so what they did was they computed it having a rational denominator. So what are we going to do? We know we can do this. We'll call this v, right? It's just some angle, 2x, whatever, v. So we'll rewrite this. This is, and you probably don't need to do this. Sine v is equal to 1 over the square root of 2. I take the arc sine of both sides. Arc sine of sine v is equal to the arc sine of 1 over the square root of 2. These are inverse functions. This is kicking the v out. V, which is actually equal to 2x, is equal to the arc sine of 1 over the square root of 2. Hopefully everybody knows that this is 45 degrees, which is pi over 4. Right? The sine of pi over 4 is equal to the cosine of pi over 4, which is 1 over the square root of 2. So we have this. And now here's where you got to be a little careful. So we know that all the solutions look like this, plus 2k pi, right? So those are the solutions. And what are the other solutions? The other solutions are going to be in, okay, so I'm going to run out of room. Let me, I guess I'll bring it up over here. So we have this. We know that 2x, which is v, which we defined as v, just to make it a little cleaner, is equal to pi over 4 plus 2k pi. And also, what else for sine? Well, for sine, it was pi minus u, right? So this is going to be pi minus pi over 4 plus 2k pi. And this is 2x is equal to this. And here's where you need to be a little careful. We need to divide out the 2 over here, right? So this, dividing out the 2 everywhere, this is going to become x is equal to pi over 8 plus k pi. And this one, what do we got here? Well, this is 4 pi over 4 minus pi over 4. So this is 2x is equal to 3 pi over 4. So this is really, okay, so let me save some space. This is 3 pi over 4 plus 2k pi. Now we divide the 2 out of everything here, and we get x is equal to 3 pi 8 plus k pi. And the first thing that I want to do here is look and see that these are in fact different answers. Those will be missing. So I guess the thing that I'm trying to get across here is before you do any dividing here, add the plus 2k pi or whatever. Add whatever you're adding and then do your division. Don't do the division first. Okay? I hope I made that less confusing. I had a feeling I just made it more confusing. So watch this section again. We're going to be coming out of this particular lecture in just a second to go to the next tape. So I guess what I'll do is I'll stall just a little bit with a joke. How many mathematicians does it take to turn a light bulb? And to find out the answer to this incredibly interesting joke, you'll have to come back. I'll see you in a minute.